Welcome to Global Information Security Society for Professionals of Pakistan.
All right, Gispp, everybody can see the screen? All right. So, today we're going to be doing Domain 5, which is Cloud Security Operations. The idea behind that we're going to talk about in this domain are pretty much what we have been talking about in previous domains, and it is a very short domain, nothing more to cover, nothing new in this that we have not talked about previously, but we're still gonna go through it through this domain, and have discussions, and you can just ask questions along the way, and we'll go from there. So, I mean, when we talk about cloud, I have mentioned in my previous discussions is that there are two aspects of the clouds. One is the client side, and one is the service provider side. So this domain, or this particular domain 5, is very focused on from the point of view of cloud security professional, cloud service provider, as to what things they need to do to provide security for their environment, the environment that they have set up for their customers to provide cloud services. And we all know that on top of the abstraction layer, which as a cloud customer we see that through web interface, through management plane, underneath is all hardware, as we have seen in regular data centers, servers, routers, switches, networks, VLANs, VPNs, all sorts of security that we are very used to in seeing in a domain environment in the organizations that we work. I mean, all those things are still bases of the cloud services. So this domain will cover logical aspect of security and some sort of physical aspect of security when it comes to cloud service provider. Okay. So let's move on to the next one. So cloud security operations. So we'll focus on securing physical and logical cloud infrastructure from beginning to end. So which includes everything from system hardening, to discuss how security technologies like firewalls fit into cloud environment. And again, when you're studying this chapter, think of it as if you're working for a cloud service provider yourself, and you are an engineer there, you are security engineer there, you are a network engineer there, you are a data center administrator over there. So put that hat on and then go through this chapter so that it will make more sense. It is not from the cloud customer point of view. So cloud security operations is all about day-to-day tasks necessary for you to protect the confidentiality, integrity, and availability of cloud systems and the data resides on them. One of the things, I can give you one example. Recently, I was doing an application assessment for one of our clients, and the application is hosted in a cloud environment. Now, that same application is hosted for that organization for multiple clients that are using their services, and the same code of that application, same database, same architecture is implemented in multiple tenants of in a cloud environment. Now, when we do, so I was doing a testing for one of their clients, which is a big financial organization, and one of the requirements that came in is that we need to make sure that we are testing the tenant that is specifically set up for this financial institution, number one. And number two is that users in other tenants of similar applications should not be able to access data for this financial institution application instance, that is the tenant that they were running. So you need to verify that the cross functioning and cross access is not there, so that we can prevent data leakage between the tenants. So that is the thing that we have to talk to the cloud security operations, cloud service providers, to make sure that the way they set up the virtual machines, the way they set up the tenants, the way they set up, user accounts are segregated, and they are not, so administrator of one tenant should not have access to another tenant in the same organization. So these are the things that cloud security operations, cloud service providers, provide that. So when it comes to implementing and building and logical infrastructure for cloud environment, as I mentioned, we start from the basics, hardware-specific security configuration requirements. So as in traditional data center, cloud data center infrastructures begins with physical hardware. As I mentioned, that includes routers, switches, servers, storage components with, NAS devices. While environment may have similarities, there are some unique pointers to consider when implementing and building cloud infrastructures. So at the core of it, at the base of it, we have the same hardware as we have all seen. And obviously, we all are familiar with the concept of BIOS, which is basic input-output system, which is a firmware that resides in every computer, your laptop, your server, your mobile phones, your routers, your switches. Everything has a BIOS in it, and the function of that BIOS is to boot the hardware and make to that point where a user can actually interact with the system. So BIOS is a chip that is in your hardware, and there are many security concerns with the BIOS, which also must be considered by the cloud service provider, that their BIOS is properly secure. And to provide that hardware level security, in addition to BIOS, now the devices that comes with a specific module, which is a microcontroller chip, and which is called TPM, Trusted Platform Module. So this is a standard that was defined, which have cryptography operations into that chip, and that provides hardware-based security. So we need to remember one thing, and also there's something that you will get in the exam, that which level of security is better. Is it a hardware-based security or a software-based security? So always hardware-based security takes precedence over the software-based security, because hardware-based security is definitely better. So what is engineer role here? So engineer role comes in later on, because engineer needs to make sure that he is or she is using these facilities that are available in the hardware. Many of the people, they have this hardware that is capable, but they are not utilizing these features. One example is, I'm sure everybody of you are familiar with Microsoft Bit. What is the name of their encryption? Anybody remember? BitLocker, thank you. So BitLocker will only work on a hardware that uses TPM. If your hardware does not have TPM chip, BitLocker most probably will not work on your system. So BitLocker plus TPM chip provides the whole disk encryption, or however you want to do the encryption. So, and in case of your hardware is stolen, your laptop is stolen, this TPM chip basically provides extra level of security on your systems. So TPM's hardware layer interacts with the software layer of security, and combined they provide a complete suite of security on your devices. And you have to encrypt your servers as well. It's not only the workstations or desktops. The servers that are in the data center of cloud service providers, they need to be encrypted as well. So in most cases, like FedRAMP, which is a US government requirement, they want their servers to be TPM compliant. Storage controller is also called a disk array controller. These are the, devices, where data is stored. And majority of the storage controllers that we use in data centers are iSCSI protocol based storage. And you need to remember that from the examination point of view, that you will get some questions on iSCSI, on which storage controllers are used and which one is better and why it is better. So these are the various aspects that you need to understand when it comes to storage controllers in cloud environment. This is a device that manages and controls storage arrays. So it is virtually integrated, integrates multiple physical storage into one single logical pool of storage and dynamically determines where to write and read data. So think of it as multiple physical storage devices, multiple hard disks running in an array configuration. And on top of that, you have a software that basically manages that for you intelligently. You do not have to worry about each and every individual disk, but the SCSI protocol is designed and the software layer that manages it for you. So for a user or for a computer, all those multiple hard disks, all those huge storage network will appear as one logical storage interface. So you don't have to worry about what is happening in the back end. So that's how storage controller works. And the protocol is called iSCSI protocol. So we talked about virtualization in the previous chapters. So installing and configuring virtualization management tool. So as you're aware, if you're installing a hypervisor on your virtual machine, so VMware hypervisor or other virtual machine hypervisors that are available like VirtualBox, those are there for managing single on a computer. But when it comes to cloud environment, you need hypervisors and you need their management interface to manage multiple virtual machines from a single interface. So these hypervisors not only provide, virtual machines, backbones, cloud infrastructure, so software-defined networks, virtualization, everything is done through these virtualization management tools. And there are open source tools available that you can install in your home, in your data center, where from a single interface, you can manage multiple virtual machines. One of such software that you can use today is called Proxmox, which is a free open source virtualization management interface. And that will allow you to manage multiple virtual machines and also set up software-defined networks. So if any one of you wants to play with, virtualization management tool, Proxmox is one of the interface that you can use and implement in your small organization. So the software name is Proxmox. Proxmox is the software that you can use to, let me show it to you. Yeah, so this is this is the software, and it is a free software. You can download it. You can set up your environment in your office and have multiple machines and manage virtualization through this. So you can do a lot of stuff. You can do virtual machine management. You can set up, software-defined networks through this one. So this is one example of the interface, and I'm sure some of the private clouds are running Proxmox as their virtualization management interface. So the reason for these management interfaces, number one, awareness. You just cannot have users run your virtual machines willy-nilly, right? You have to have an inventory of what people are spinning up. Again, in an example of PaaS service model, users can spin up virtual machines, developers can spin up virtual machines, and administrator might not know about it. So in order for administrators to have an awareness that how many virtual machines are running, how many virtual software-defined networks somebody has set up in the organization so that do not go unnoticed and unrecorded, because if you do not know something that is running in the environment, you cannot protect your environment. So these software-defined, management interfaces, virtualization management tools gives awareness so that you know what is happening in the environment. They also provide you automation, right? So what happens is that you can create standardized virtual machines and make them available to users as and when they want to spin it up. Example, again, go to Azure environment, go to AWS, and in a free tier, actually they provide you a list of virtual machines that you can just click and spin it up. And all that is happening through the virtualization management tool, which is an abstraction of actual on top of physical hardware running hypervisors on them. So continuing with operating physical and logical infrastructure for a cloud environment. So now we have physical, again, think of it from a cloud service provider and their team who is running that cloud infrastructure. So we need to make sure that at the hardware level, obviously we use KVM switches, which is keyboard, video, mouse. We also access our devices through console, whether it be a Linux command line, whether it would be a Windows PowerShell, or whatever the case may be. So you can access your computers, you can access your servers through those consoles, and which is mostly command line interfaces. Then you have remote desktop protocols, which is, we all know Windows has remote desktop protocol that runs on port 3389. You connect an RDP session, you have a Windows interface in front of you, a remote server you can see as if you are on that. So these are various methods that an administrator in a cloud service provider can use to access backend servers. But you do not want to have this access open to everybody in the cloud service provider environment, right? So you need to make sure that keyboard, video, mouse, which is a physical device, is properly secured. And usually in a data center, in a cage where you have multiple servers, there is a one slide out tray which has a single keyboard and a mouse. It's connected to all those servers in a cage through KVM switches. So we need to make sure that KVM is locked, encryption is enabled, and physical security in place. And one of the basic physical security is that nobody should have access to the data center where these keyboard, video, mouse devices are stored, and only authorized people can access that data. And it's a very basic physical control. Console-based access control, we need to make sure that you cannot just SSH into those servers using Linux command line or a Windows command line. We need to make sure proper access is set up for SSH-based. Users' accounts are properly set up for SSH-based access. You need to make sure you are using proper, strong encryption for your SSH level access. So those are the considerations that you need to make when you're doing console-based access. Remote desktop protocol, you need to make sure that it is not open over the internet. RDP should only be used strictly inside the organization, number one. Number two is that we need to make sure only authorized users in a proper remote RDP group in Windows Active Directory are set up so that no one else other than those authorized users is accessing servers using RDP protocol. And on top of that, logging and monitoring needs to be enabled so that we all know who is accessing and who is trying to access this thing. So that visibility is very important in all of these three cases. So all of these access methods should require multi-factor authentication and a thorough logging and monitoring at a minimum. So as I mentioned, at least make sure that MFA is enabled. Again, if anybody have you, and if you have worked with AWS, when you spin up a machine, AWS sends you an information and sends you an email, I think, as well. And you can set up MFA within the AWS. Without it, you cannot access the machine. So MFA is very, very important when accessing by any of these means. So which one should, so the question is that most hardware vendor offer their own KVMs, and third-party KVMs are also available in the market. Which one should be selected on what basis? So first of all, we need to look at their physical security. They should not be tampered easily, number one. Number two, they have proper encryption enabled in them. Number three, their software, which is running on the KVM switches, is properly vetted, and it provides access control mechanism. It provides built-in encryption. It provides built-in communication encryption, because what you're doing is you're sending keyboard and mouse strokes over a wire to multiple systems, right? Now, if that keystroke, that communication is not secure, data in transfer and transition, then anybody can actually tap that communication line and listen to those keystrokes that you are sending over the network sometimes, or over directly connected through a KVM switches. So there are security parameters you can actually look up. I think NIST has a guideline on how to select these KVM switches, and there are standards that are available that you can use to identify what is a secure KVM setup. And based on that, you can create your requirements and ask your vendors that if they meet those requirements. So there are KVM standards out there that you can look up and buy products that meet those security standards when it comes to KVM. Okay, so move on. So next one is secure network configuration. Again, we talked about whoever has worked in network or manage a network on Cisco side, or have ever a title of network administrator in the past, or if they are currently network administrators, we all know network segmentation is a key factor in securing your internal network. So for that, in order to provide network segmentation, the technology that is available is called virtual local area network. So what happens is that usually when you set up a network, it is a flat network. But flat network means that devices and servers are connected to each other via hub or via a bridge or other connecting mechanisms, and each and every device is seeing each and every other device on the network. They are broadcasting traffic. There is no traffic isolation that is in the network. So VLAN actually solves that problem of virtually segmenting a physical network, which so that you can have segregation of various components in the network. And what we achieve is we achieve segregation, and we achieve isolation of traffic, and we achieve security. So for example, users on a network should not have access to a network segment that is hosting all the servers. Right. So in a cloud service provider environment, cloud users in that environment, service provider, they should not be able to access servers that are running virtual machines, that are running client, that are hosting client data. So you need to have that segmentation, and VLAN provides that segmentation in there. So it provides, so you can separate production environments versus development environments. So you have developers who have their own environment, they are doing development. So they have their own VLAN, and the data from that VLAN cannot leave that VLAN, and data from other VLANs cannot enter that VLAN. So that provides a segregation. Separating tenant environment from one another. So this is the example that I was talking at the beginning of this slide, that when you are hosting your system, you need to talk to your service provider that, you know, your tenant, your data should be separated in a separate VLAN so that there are no data leakage, right? And how, you know, you can achieve that? You can achieve that through software-defined network. So software-defined network does provide VLAN capability. As we have seen in the past, you go into a Cisco router or a Cisco switch, and you not router but switches that provides this VLAN capability. Separating different zones, planes, or tiers within your environment, for example, management, application, and data tiers, and segmenting storage controllers from the rest of the environment. So you have to create these separate segments in your environment and to provide security, because flat network is always unsecure. And this is all the considerations that we are talking about right now. Again, these are all from cloud service provider perspective. Next one is TLS. So we all know SSL has been replaced by TLS protocol, which provides data in transmission security by encrypting the data. And you will get question in the exam regarding TLS and what is a TLS record protocol versus what is a TLS handshake protocol. The way probably you're gonna get the question is you're gonna get the definition of either of them, and they will ask you what protocol is that. So it is, in my opinion, it's important to distinguishly understand what is the definition of each of them. So the TLS record protocol, this actually provides secure communication methods for data in transit. So it ensures data confidentiality by encrypting the correct connection with symmetric key. That's another hidden question, that what kind of encryption used by a TLS protocol? And generally they will ask you, is it asymmetric or symmetric? So you need to remember that TLS is a symmetric encryption key protocol and validates data integrity through the use of hashes and checksum. So it used to encapsulate various upper layer protocols, mostly notably the TLS handshake. So third thing to remember is that TLS handshake protocol is encapsulated in TLS record protocol. So there's a lot of information in this slide that is important from the examination point of view. You will definitely get one or two questions from TLS. So the next one is TLS handshake protocol. This allows two parties like client and server to authenticate each other and negotiate the parameters for TLS connection. So again, as the handshakes implies that, you know, before we start any communication in your regular day-to-day environment, you shake hands with each other before you negotiate and before you communicate each other. So that's what handshake protocol does. It lets client and server agree upon and negotiate the parameters of authentication, session ID, and what encryption algorithm to be used. The entire handshake process occurs before any secure data is transmitted. All right. So this slide is important. The next one is DHCP. We all are very familiar with what DHCP is. It is a dynamic host configuration protocol. Either you assign, IP address, a static IP address to a server or a workstation, or you set up a DHCP server to assign IP addresses dynamically as and when computer or system come online. However, in cloud environment, it is important that you give static IPs to servers, because nobody likes that server get their IPs dynamically and it changes every few days or few hours, because it's gonna create a mess. However, in virtualized environment, when you spin up a virtual machine, those machines get IP addresses from DHCP pool, because machines are very more dynamic than servers, because users are unplugging them, plugging them back again. They are traveling with those machines, so you cannot have a static IP address to those machines, in generally speaking. So DHCP obviously is one of the core backbone of computer network. So on top of DNS, there is another technology which is called DNSSEC, or DNS Secure. So DNS Secure is an extension, a security extension of standard DNS that supports the validation of the integrity of DNS data. So we all know how DNS works. It's just like DNS is just like a phone book, right? If you want to look up something, you go to phone book and you look up a person name, and then you get the IP phone number of that person. So that's the same principle DNS work. So you have to go to an authorized DNS server or authority server, which is kind of equal to a phone book, and then you query that server that say, hey, I want to go to google.com. What is the IP address? And the authority server basically replies back with the IP address, and all that communication works. But there is a chance that their DNS spoofing might be happening. Somebody has set up a fake authority server or a response server, where if I type google.com, my computer goes to authority server, which is a fake server, a DNS server, and gets an IP address of a malicious server, right? So I'm bypassing the security. So in order to provide that integrity, in order to provide that security, DNSSEC makes sure that when the client requests, there's a cryptography signature associated with that validates the origin and authority of DNS server that responds to DNS lookup, right? So the primary attack against DNS target availability and integrity. So DNSSEC is great for ensuring DNS integrity, but does nothing to protect the availability of the DNS resources. So which is important point of remember. So if you look at CIA, which is confidentiality, integrity, and availability, DNS only provides confidentiality and integrity. It does not protect the availability of DNS resources. There are other security controls in place that provides that availability. So standard denial of service and other availability controls must be used to mitigate availability attacks on DNS services. One thing to remember, if any of you wants to, thinking of enabling DNSSEC on their servers, you might break a lot of sites, because many of the sites on the internet are still not DNSSEC compatible. So if you set up your own DNS server in your organization and you enable DNSSEC, then some sites will work, some sites will not work in your organization if you have managing your own DNS server. I have done that. I have learned my lesson. So just giving you a heads up. Okay, so the next thing in cloud operations is hardening of the system. Hardening the operating system through application baseline. So we all know that there are things called golden images, right? So those golden images are the image. So golden images is a term that is used for an operating system image that is secure, that has been vetted, and that has been good to go to install in an organization with all the required security parameters set up, right? So that's what we call a golden image. And by image, I don't mean picture. By image, I mean that actual file, the secure operating system file that you install. So you have to apply your baseline security, and you set up those servers, routers, switches, and workstations and laptops. So that concept, same concepts apply in cloud. The problem with cloud is that it is more dynamic than your regular data center. It is more fluid than your data center. So the chances of what we call drifting, so this is the term that is being used a lot in cloud these days, that we have a security drift or secure configuration drift. What does that mean? It means is that you have set up a server, you have set up a workstation in the cloud, and over the course of time, or maybe services like Office 365. So over the course of time, as people are, as administrators are managing those things, their baseline security get out of whack in a way that, it was secure. Some guy go in and say, oh, I think this, security setting is not working, turn it off. Or I need this port open, which was required to be closed, and that person went in and changed that port. So now what's happening is there's a drift that is happening in the security configuration of your cloud environment. So it is very important. Sorry? Hello? Somebody's mic is open. All right. So we have to, in the cloud, we have to be very careful about these security drifts, because if these drifts are not managed, then your application or your software becomes out of compliance. Anybody heard about CIS benchmarking? Okay, so CIS benchmarks are, let me just show it to you over here. So CIS benchmark is this site where you can actually download security baselines for various things. And if you can see over here, we have operating systems, server software, cloud providers, mobile devices, network devices, desktop devices. And for cloud providers, you can see they have Alibaba Cloud, Amazon, web services, multiple cloud and service providers. They have their benchmarks. And you can then actually download these benchmarks. And let me see if I can find something that I can, like Microsoft Office. So we have done an assessment for one of our clients where they have Microsoft Office 365 in the cloud, and they want us to set up security of their cloud, making sure that data leakage can be prevented. They want to set up MDM, they want to set up Intune. So, but they do not know how to secure them. So what we did is we actually went to the CIS website, we download benchmarks PDF, and you can get, they're free, you can download it. And we went one by one, line by line on each setting, and make sure that their cloud environment is, Office 365 SaaS environment is properly set up and secure in meeting our clients' compliance requirement. So healthcare industry, financial industry, banking industry, and many other industries have their own standards, right, of federal government. And these benchmarks basically comply with the, help you get in compliance with those requirements. So now the problem that was coming in is, I'll keep that open. So the problem that came in, that we did that security configuration, we established that baseline for that client a year ago. And after a year, when there was a compliance audit for their cloud environment that happened, it was discovered that a lot of security settings that was originally set up were not there anymore. In short, what happens is that their security environment got drifted. There was a drift that happens and their environment was not in compliance. So one way of doing that is to every 6 months, somebody has to go in, somebody run, go through the CIS benchmark, making sure all security settings are there. And then, it's a continuous process, a manual process. So which was very hectic.
Okay, question here. If I open this PDF, it's like 1,000 pages.
Yep.
So how we will know, like, should we do every step, whatever mentioned in the PDF,
Hmm.
or we should do it as per our organization need? If it
Yes.
is as per our organization need, then
Hmm.
how we will know this is our organization need?
Hmm. Yeah, that's a good question. No, you do not have to do each and everything because, if you're in Azure environment, then you have to run PowerShell commands, a lot of it. In AWS, and you have to run AWS specific commands to have that security. So it's a very painful process, right? So first
Correct.
thing you need to determine is that what's your organization compliance requirement. If it's a regulated industry like financial and medical industry, right, or pharmaceutical. So from that, or if a PCI DSS, right? So you need to look at those standards, and from those standards, you find out what security requirements apply to your organization, right? And that's your baseline. Once you establish that, then you select controls from the CIS benchmark as to what needs to be implemented in your organization, right? So that's the process. It does require a little bit of homework. It does require a little bit of understanding. It does require a little bit of understanding of your organization business, and all the regulation requirements that governs that business of your organization, right? So now, if anybody is interested, there are tools that are available now help you implement these things, right? Azure has something called Security Center. I think that's what it's called. And what it does is that it has automated that process for you. So you log into Azure portal or AWS portal, and they have this security interface, security management plan, where all of these benchmarks are listed for you. And what they do is they basically scan your cloud environment, your tenant, your cloud environment, and give you a report where you are not in compliance, uh, according to these or according to the settings that you have done. So they have made that a little bit easy for you. So you can scan your cloud environment for compliance through those interfaces. That's one aspect. That's one way of doing it. So what we are doing right now with our clients that are in cloud, and they have these baseline requirements, baseline security requirements. There are tools, other tools. If you have used Nessus, anybody have used Nessus in their jobs? All right. So Nessus is a tool that is very near and dear to me. I mean, my pretty much my whole career is built on that tool, starting back from 2001 when I started using 2003 when I started first using it. So Nessus now has the capability to do policy scans or policy audits. So we all know we can do you know network level scans, vulnerability scans. So that is one aspect of Nessus. Second aspect of Nessus is to do a policy audit, right? And that policy audit is based on CIS benchmark. So you can download a benchmark, and Nessus comes with all of these policies actually built in. You don't have to do anything. They are there for you. You actually connect to the cloud via API authentication, and you can scan your cloud environment using Nessus. You can do vulnerability scans of your cloud workload, and you can also do policy compliance and configuration review of your cloud environment using Nessus. So that's a good tool. You can use that. But for larger environments, where the tools that we are using right now that is being very popular, at least in the US, it's called Prisma Cloud. Let me. So this is the tool that is by, I think, Palo Alto. And this tool basically provides that information, insight into security drift that I was talking about. And this tool, what happens is, if it finds, it is constantly monitoring your cloud environment, whether it be Google, AWS, or Azure, whatever the environment is. It is constantly monitoring it, and then it is reporting back if any of your tool, if any of your security configuration is not in compliance. So this is a good tool that is available out there. So There are multiple solutions out there like Prisma Cloud, like Nessus. Depending upon your organization size, needs, budget, you can select those and making sure that you are in compliance. Any questions? Okay.
Are there, Rehan bhai, these tools can do this benchmarking scanning for OS, like for the offline or standalone environments also?
Nessus can do that, yes.
Okay.
Yep, Nessus can do that, and Nessus can do these scans for your on-prem systems.
Yeah, probably we can do it based on a single IP. We can base. I did it for single IP, probably not for the whole subnet, because I had that much permission only.
Yeah.
Okay.
So have you done the network level scan, or did you do the policy audit?
No, it was like if one, I had a specific KVM technology, I was doing it. So I connected it over the network. Then my security team asked me, okay, run this Nessus scan. And there was another one. Two, I used it to scan that particular technology only because I was not allowed to do all other things. Otherwise, they can block my access.
Yep. Okay. All right. So next one is availability of standalone hosts. So sometimes organization needs standalone systems within a computing environment. So it's a physical machine that operates independently from other machines in an environment. So standalone hosts are commonly used in traditional data center models when it's desirable to isolate one system from another. So whether for security, compliance, performance, or other reasoning. Although less common standalone hosts are still being used in the cloud. And one of the usage or use case of using a standalone system is what I think, in my opinion, is using a jump server. Anybody familiar with the concept of what a jump server is? So jump server basically is a standalone system that allows access into cloud environment for only specific purposes. So again, so if I am working for my client and he wants me to test something in the cloud, now I do not have client network internal access. So what happens is the client set up a jump server for me where I go, where I log in from outside, maybe through a VPN connection, and I can access that jump server. And from that server, I jump into the cloud environment or their environment. So that is why it is called jump server. So that might be another example of a standalone system that is set up in the cloud environment or in your data center to provide vendors or provide, for support purposes for outside vendors to provide support for your organization. So that's another example of a standalone host. So jump server is a good example. Then we have clustered hosts. And that's what basically what cloud environment is. So it's a group of hosts that physically or logically connected in such a way that they work together as a single host. So again, these are multiple computers clustered together, managed through a software interface that is designed to manage one cluster. So each host within that cluster is set to perform same task. So all those computers in that clusters. So basically, it's a pooling of resources. You have multiple hard disks, multiple processors, and you collect them, you clustered them, and you are asked, and you are basically assigned them to do one task. That task may be data processing. That task may be, for setting up a artificial intelligence network, or machine learning, or whatnot. So you collect multiple computers and do one task, or maybe Bitcoin or blockchain technology is a good example of clustering. So resource sharing concept, like if you remember, we talked about reservations, we talked about limits, and we talked about shares. They help orchestrate and manage resource allocation among tenants using the same host cluster. So again, in terms of cloud environment, the idea of limiting, the idea of sharing, the idea of reservation, that are managed through the clustering software where it has multiple physical computers behind that software working as a cluster. Okay, we are pretty much to the end of this training. It's not, as I mentioned, it's not that large of a domain. So operating system baseline compliance, monitoring and remediation. So again, we talked about applying baseline is an important step towards ensuring consistent and secure operating systems, but it's far from set it and forget it process. Again, referring back to the idea of drifting, you just cannot set up a baseline and forget about it, because over the course of use, over the course of time, the configuration drifts and you may become out of compliance from security. So that's where those tools there, that's where monitoring comes in, and that's where you have to have these tools in your organization. So once OS baseline is applied, it is important to ensure that system remains in compliance with those baseline through continuous monitoring. And, you know, Nessus, Prisma Cloud provide that continuous monitoring. Compliance can be accomplished by using configuration management. We all talked about what configuration management is, that you just cannot go ahead and make changes without any approval. It has to go through a proper change management and configuration management process in your organization. And you load these tools with your approved baseline for each OS and scan your infrastructure to detect any non-compliant system. Again, idea of drift. So we need to make sure that drift does not happen. And only way we can ensure that drift does not happen is continuous monitoring. Okay. So the next one is performance and capacity monitoring. So performance monitoring is a critical task that every cloud service provider must perform on a continuous basis to ensure that systems are running dependably and customers' SLAs are being met. So you remember that a cloud service must be available 99.9% of the time. So, and that's where performance and capacity monitoring is very important. So if you are, as a customer, acquiring a cloud service and talking to a cloud service provider, you need to make sure that their performance and capacity meets your requirement and there is no downtime as they promised in their SLA. Because if on the cloud service provider side, they agree with you that you have 99.9% uptime, but they are not monitoring their performance and capacity, and they go down, then they are in trouble because their client can sue them, their client can move to a different service provider and whatnot. So it has business implications for the cloud service provider. So performance monitor involves routine collection of an analysis of performance metrics for key components of the cloud environment. So key components that should be monitored, including network, compute, disk, and memory. So when conducting performance and capacity monitoring, it's important that CSP consider their ability to support all current customers, as well as their capacity to support auto scaling and future customer growth. So these all things go into planning, right? So if you are a cloud service provider, or if you're thinking of becoming a cloud customer provider or service provider, you need to think, you need to understand, you need to look at future growth. You need to make sure that you identify key matrices so that you monitor them and make sure if anything happens, you have a backup plan and you are able to address those performance and capacity issues without any downtime for your client. Then we have network security controls, again, just like our data center that we have in our organizations. Cloud service provider is a large data center, and it has to have all those basic controls, network security controls in place to protect that network. And those basic controls are firewall, intrusion detection systems, IDS, and IPS. So firewalls, you already know what they are, how they work, very basic. IDS, IPS, one thing I did not put in the slide is, and you probably get a question on it, is what are the two different types of IDS, IPS? So the two different types are host-based IDS, which is server or that installs on server and workstation, and then you have network-based IDS, which basically look at the network as a whole itself. So these are the two basic network level security controls that cloud service provider installs in their data centers. Next one is management plane. From cloud customer perspective, we talked about management plane, how important it is, how important the security of management plane is, because if a malicious user get access to your management plane, cloud management plane, then he will have access to each and every aspect of your cloud service. So this management plane, so remember we talked about looking at physical and logical security of cloud service provider. So management plane is the logical aspect of that. So managing the physical and logical infrastructure of cloud environment requires effective task and operations scheduling, efficient orchestration of activities and resources, and comprehensive yet minimally disruptive maintenance. So all of these activities takes place in the management plane. And management plane usually is a web interface that cloud service providers use themselves. And we as a cloud customers also use management plane to manage our cloud environment. So what does management plane provide? It provides many features, such as scheduling. So they can, cloud service provider can use scheduling as is the process of taking customer resource requests and prioritizing those requests in a way that available resources are assigned and utilized more efficiently. So most of this part is automated, right? And cloud customer have access to these features where they can, scheduling their resources and request certain, these resources from their cloud service provider through management plane. Orchestration is basically very, very essential component of cloud management. Is basically organization integration of automated tasks between system and services in the cloud service environment. So cloud orchestrations allow you to create a consolidated workflow from multiple interconnected process. And the way I remember orchestration, or the way I understand orchestration, is I got to upload, if you have seen, that big musical in a big hall, and you see there are multiple musicians sitting and playing different instruments, right? Somebody's playing flute, somebody's playing piano or whatnot, but there's one guy with two sticks who is the orchestrator, right? And that guy is basically with his stick controlling that whole big group of musicians that are sitting in front of that person. So that's how I vision of what orchestration is in cloud service provider, that you have this orchestration piece that is responsible for managing various aspects of cloud automatically. So that's what basically orchestration is. So orchestration. So this is the last slide. We have talked about these individual things in previous domains. And so implementing operational controls and standards, these are from the cloud service provider perspective. So cloud service providers need to understand change management, continuity management, which we talked about, business continuity and disaster recovery planning, information security management. We talked about this in the past, continual service improvement. We just talked about it. We also talked about in the past incident management, problem management, release and deployment management, configuration management, service level management. We briefly talked about it, availability management, and capacity management. So these are various controls and areas that cloud service provider should look into when managing operational and physical and logical security controls in their environment. So I think this was the last slide. Any questions?
Yes, I had one question, probably you don't look at it in the chat. It was about not TPL, TLS. So this protocol, if we want to implement it in our environment or wherever, is it technology based, or there is a solution which can add this protocol in our environment?
No, it is part of, so, when you go to a secure website, right? your bank website or any other website. So that protocol that your browser is communicating with the web server, that is happening in the background, and that what TLS protocol is. So you can enable that in your web server, right?
So
It used
it
to be
means
SSL. Yeah.
okay. So it means it's provided by the technology, like
Yes.
whatever technology we're using, it is
Mhm.
technology provided. Yep.
Yep.
Okay.
It is in there. It is already built in. So all the new browsers, web servers or other devices that requires that, it comes built in it, right? All you need to do is you set up and configure it. That's it.
Okay. And for the CS benchmark, is there a tool other than the cloud environment? If we have an offline environment, we want to do the benchmarking for
Yeah.
our tool like PCs and servers.
Yeah. You can use Nessus. Nessus, you can do
Uh,
that for you.
Okay.
Yep. And CIS also has their own tool. If you go to their website, they also have a tool. It's not very expensive. You can buy it. And that tool, you can install it, and it has all the CIS benchmarks built into it. And you can run those tools in your environment and do this baselining.
Wow. So it can implement it can implement those changes also, right?
I think it only detects the change. It does not make changes.
So it will scan only and it will give me report where I'm lacking. That's it.
Yes.
Okay.
It's called
Okay.
CIS CSET tool. I think it's free. So it's a free tool for assessing implementation of CIS control, and it will give you this type of report.
Okay, because I'm a lazy dude, so I want to do something like, okay, I will click on it. I want to implement this. It will connect to my Active Directory and it will make all those
Mhm.
changes, which is fine. One more question. I will look at it
Oh,
though, for sure. This
by the way, if you want to push out those changes, all you need to do is go into your Active Directory group policies, make those changes, and push it out to all the computers. You don't have to go each and every computer.
yeah, that I understand. But even to make in the Active Directory, like I have to search for every policy and then I will make the changes.
No, no,
One
there are
more.
tools available out there to do that for you. Okay, go ahead.
Okay, those changes are available as a script somewhere. Like
Yes,
I can get a
those are
script
available. Yes, those are available.
from the same site.
From the same site, and also I'm not sure if that site is available, but there is a site called uh, NIST uh, Golden Image, I think. Yes. So if you go to this, it's called USGCB, United States Government Configuration Baseline, and they have all of these already set up in a group policy format, and you can download and
Wow,
apply. Yeah.
that's it. You made my life, man. This is the easiest one. Ah,
Okay.
this is amazing. One more last question. This baseline, when we talk about the baseline, should it be a part of our standard image, or once an
Yes.
image boot up, then we
No.
implement those policies?
Good question. So remember I mentioned golden image? So that
Yep.
golden image has all of these settings already set up. So once you create an image, you make that image, and then that is available for you for server, workstation, whatever. And then when a new computer comes online, you just install that image with all those security settings. You do not have to do anything because it's done once and used many times.
I got it. I got it.
Yep.
Because like I can give you example of my own environment. Like we are one of the companies who are still building these things, and we are in the process of evolving these things gradually.
Yeah.
But we don't have right now a standard imaging thing in place, so
Yes.
we are lacking on this standard. In
Yeah.
that case, if we don't have a proper tool for a proper imaging and image implementation,
Yeah.
probably this could be a start. We can implement it by policy, but that
Yeah.
will not be a good practice, correct?
Yeah. So one thing if you are selecting any tool for this purpose that you want to do policy enforcement of this, make sure that tool is SCAP compliant. So this is the term that we use. So you can this is a security content automation protocol. So all that security content, that policy, right? It's a content, right? password security and all that. These are
Yes.
contents, right? So all these tools, if they're SCAP compliant tool, they will do that for you. And they have a list of all these tools that are in compliance with that. So this is a whole separate topic that we can talk about some other time, but this is available, and these are SSL compliant tools.
Shahzad bhai, please note this. We will have a session on this one.
Yeah, so for Linux, just give you a quick example. So I do a lot of SCADA work, industrial control system security, and majority of that industrial control systems, they are isolated. They are very sensitive systems. They're not connected to the main network, and you cannot scan them, right, over the network because they may go down because they're very sensitive. So this is OpenSCAP is a project where basically you can run this tool on a Linux machine, and most of those machines are Linux machines, and run it locally on the machine, and it will generate a report for you where they are in compliant and not in compliance. So this is another tool that runs locally on the machines if you do not have a network access to certain machines and you want to make them secure. So this is a free tool. All right. Any other questions?
I think so. I'm good.
All right. All right, guys. Thank you very much for your time today. And we'll meet next time for the last domain for
Inshallah.
CCSP. All right.